A data workflow is the orchestrated sequence of tasks involved in processing and managing data from inception to analysis. Defining and modifying workflows in a cloud data warehouse is therefore a business-critical activity. Inadequate workflow management is not only costly, it can lead to poor performance and ultimately incomplete failure to deliver business information on time. Let's face it, workflow management is not easy. The entire process typically requires a plethora of tools that need to be integrated. Also, solid programming skills are a requirement. Making changes to workflows can therefore be very complex and time-consuming. As a matter of fact, it is not uncommon that organizations shy away from making changes on the go. Agile Data Engine aims to solve this problem by providing a single platform. There is no need to integrate and maintain various tools while providing nifty and rich capabilities to dramatically simplify this work. Before we look at how we do this, let's explore how workflows are managed in ADE. Agile Data Engine generates workflows automatically based on entity dependencies defined in load entity mappings. By default, all loads of dependent entities within a package are automatically placed in a workflow and visualized in the workflow's view of the ADE designer. In the example shown, there are 4 different workflows related to a data product. It gives a clear picture on load dependencies, and it's easy to navigate through them. Let's now select one of the data warehouse entities. The view highlights its incoming and outgoing loads, and it gives an option to focus on a single entity to get a clear picture of the loading process. In the case shown, the table is loaded by 3 different workflows. Before we look at how workflows are defined in Agile Data Engine, let's explore some typical workflow definition scenarios. In example 1, the schedule is defined only for the first loads of each pipeline on the staging level. Both data warehouse and publishing layer loads inherit them. In other words, once the data appears in the source, all outgoing loads related to it are subsequently executed. The execution path is determined by the dependencies between entities. As a result, 2 separate workflows will be generated, executed independently. The publishing load will run every time the staging area is loaded. This is typical for time-critical scenarios, but it is database-heavy and thus potentially costly. In the next example, the chain of dependent loads can be broken by explicitly selecting a different schedule for a load. As you can see, the data warehouse loads inherit schedules from staging loads, Schedule A executed in 5 minutes interval and Schedule B run every 6 hours. The downstream publishing layer load is therefore also executed every 6 hours. This approach is less database intensive and also less costly. In order to make publish layer load the driving one while preserving dependencies, in ADE, it's as easy as assigning schedule to the publishing layer load. The final example shows a multi-dependent load with its own schedule. This is typical when an object has multiple incoming loads. Loads between layers become independent and isolated. This is a cost-effective option, and it is often utilized if the publish layer doesn't require frequent updates. Okay, let's see how we define and modify workflows in ADE. Let's take a look at this example where 2 workflows are assigned to a published data product. Both are executed every time a related staging table is loaded. Let's change the refresh frequency for the publishing objects to every 6 hours. First of, ADE allows you to configure definitions of reusable schedules globally. This helps to tremendously reduce manual rework. Each schedule has its name, description, tags, and the execution formula can be defined as a common cron expression. Schedules can be assigned to a pool, and there are various generation modes available. You also have the freedom to define schedule triggers and variables. In order to break the existing chain and assign a 6-hour schedule to the publishing layer, it needs to be assigned to the incoming loads. The details of the schedule are read when it's selected in a load. And here we go. Not only the publish object we assign the schedule to forms part of the 6-hour schedule, but also dependent objects. With just a few simple clicks, we change the load patterns. No coding required, and this took just a few seconds. Notice that the three workflows were updated accordingly as well. The publishing layer object is not part of them anymore. What would happen if only one of the loads were updated? Thanks to ADE's workflow management flexibility, a hybrid solution would be created when one of the loads forms part of the original staging to data warehouse to publishing layer load, and the other is assigned to a 6-hour schedule. DAG generation mode determines how the tasks in a workflow are formed. It can impact performance and can also affect parallelism. By default, generated workflows are load-based, generated according to dependencies defined in ADE. There are situations where it makes sense to change the orientation to entity, especially in a situation where loads block each other in the target database due to multiple parallel loads run. In that case, all relevant loads are executed in a sequential manner within an entity node. The changes are reflected in the graphical representation of a workflow. There is also another mode called sequential task-oriented, which minimizes scheduling overhead, especially useful for near real-time cycles. It limits parallelism and monitoring, though. DAG contains one main task, plus start and end, and selects running order of loads which are not dependent of each other randomly, but obeys original order of dependent tasks loads. ADE automatically generated more than 5,000 lines of Python code to run the DAG and Airflow for the sample workflow. Manual handling of such complexity would have been time-consuming, error-prone, and challenging to adjust. In ADE, workflows can be initiated in several ways, offering flexibility in their execution. Usually, they're scheduled using cron expressions. When workflows have interdependencies, they can trigger upon the completion of their dependent workflows. Additionally, a workflow can be executed by itself. Integration with external tools allows running or checking workflow status via API calls. For development, testing, or fixing production runs, data loads can be manually triggered, offering convenience in these scenarios. In summary, ADE provided us with a powerful capability of defining and modifying end-to-end data workflows quickly based on system dependencies or individual needs. It reduces manual intervention, operational overhead, human errors, and ADE facilitates complex scaling and setups with hundreds of loads and helps pinpoint performance bottlenecks. In addition to that, it helps avoid costly configuration and administration of external tools,